So everyone can see my screen?
I can see it, so
Yeah,
looks
we're
good
good.
to me.
We're good,
Yeah.
Francois.
Okay, awesome. So let's start with the Ultranix installation and startup. So this is a KingHome product. As you know, we are a GUI distributor. So what is the Ultranix? The Ultranix, it's a air source. It's a heat pump. Well, it's a unitary heat pump. Very efficient. You can operate the unit till minus 30 degrees Celsius to 44.5 degrees Celsius. You can get 100% capacity at minus 10 degrees and really quiet units. And it's very flexible regarding the installation on any types of air handler or furnaces. Or all you need is a case coil with a TX valve. We're going to see through this presentation how we're going to install those big guys out there on the field. So in that heat pump, you have a two-stage inverter compressor. And so it's really a good compressor, really reliable. Can go, as I said, to operate like 100% of its capacity at minus 10 degrees Celsius. This unit is fully 24 volt compatible. So even through your thermostat to the outdoor unit, well, it will be a 24 volt connection. There's no communication line on this unit. So all you need to connect is your 24 volt wire and your high power, your power wire as well. And it's compact. Like, it's not like those whole big heat pump system that you will have on the side of your house. So this one is side discharge, so it will be very flexible, and it's very fun to install as well. So today we're gonna see how to be prepared for your installation. We're gonna walk through the indoor unit, the outdoor unit as well. We're gonna take a small review about the piping, pressure, vacuum, all the stuff you need to do to be done perfectly when you want to do a good installation. We're gonna see the electrical wiring, and at the end of the presentation, it will be a test and run how to control to make the startup for the unit, how to program all the stuff via the dip switches and how to make it work correctly. So first thing first, every time you will do a job, make sure your ductwork and the equipment is compatible with your load calculation. So this is according to the ACCA Manual G residential load calculation. You need to match a good load calculation from the houses you're about to install the unit. If it's undersized or oversized, it will not be efficient enough in cooling or in heating. And just be sure that you will have the right ductwork, the right amount of CFM running through this unit. So when you are on site, you want to make sure that when you will locate this outdoor unit or your indoor unit, well, you will be aware that the noise will not disturb the neighbor, to have a proper ventilation around the unit, to make it like strong and a safe installation, away from flammable corrosive gas, away from strong wind. This is the one I want to highlight a little bit, because in heating mode, You just want to make sure that you don't want to let the wind make the job of the outdoor condenser fan. So just be aware that away from the strong wind is an important thing. Away from object that may generate noise or high enough to have an easy condensate drainage. When you will do your electrical stuff, well, safety is a thing. So always make sure you are conform to the nameplate of the unit. You will have a stable rated voltage. So it can be as low as 187 to 253 volts. So be sure the voltage is stable. Always make sure you have a proper grounding also. This is very important. And the use of a surge protector is highly recommended too. You have a lot of electronic boards inside of that unit. Maybe you can the house can be hit by a lightning strike, something that can cause higher voltage. So the surge protector will prevent the issue that you can you can damage a board or something like that. So just be aware that a surge protector is highly recommended on all those installations. We're going to move forward to the indoor unit now. So KingHome has a hair handler, electric hair handler, matching this outdoor unit. So you have different selection of unit, 2 ton, 3 ton, 4 ton, and 5 ton. You can also match electric heater to it. Regarding if you have a 2 ton air handler, you will have a 5, 8, or 10 kilowatt compatible. You cannot install a bigger than that. But regarding what kind of unit you are installing, well, you will match the proper duct heater to it. You can also just take a look that every size from 2 ton to 5 ton, you will use the same piping diameter. So the liquid line will be always at 3/8, and the gas pipe will always be a 3/4 pipeline for the refrigerant. So you have 2 different style for the cabinet, 2 different dimension. So if we're looking to a 2 or 3 ton, you will have a cabinet that it will be 21 by 21 by 48. The height will be 48. And if you have a 4 or 5 ton unit, well, it will be a little bit larger, so 24 by 21, and a little bit higher, like 57. Also, make sure that you know exactly the dimension for your duct, the supply duct that will match the A and B distance right here. The thing is, in this type of air handler, the top panel right here needs to be accessible for servicing or to make an easier installation where you're on the field. So if you guys are about to install some kind of air handler, just be aware that the first part of your ductwork must match this dimension here to make an easier access on for the top panel right here. So what's inside of it? When you open the panel, you will find an electrical box. So the board is right here inside of it. You will get here your centrifugal fan, your fan motor. It's a DC 3-phase fan motor. You will have the coil assembly right here and a secondary pan drain. So this unit can be installed vertically or horizontally. and you have your primary drain pan as well. So if your installation is vertical like this, you just make sure you have enough space around the unit to provide a good service around on that unit. So you will need to have access to the top panel right here. You need 24 inches minimum in front of the unit, but side by side it can be as close as 1 inches. So and in the back too, but in front of the unit and to get a good access on the top panel here is a good thing to know when you're installing those here and there. If it's an horizontal display like this, well, if you lay down on the left, well, the drain pan is already on the left side of the unit, so you don't have to change the configuration. But if you flip it on the right side and you have another horizontal right configuration, so yeah, at this point you will have to relocate the pan, the drain pan. So you will have to remove that coil, change the secondary pan here to flip it on the other side, and then you're good to go.
Hey, Francois, it's John. Question for you. Are there any baffles that need to be installed when it's horizontal installation?
No baffle at all. The airflow will flow through the A coil. So the only thing you have to do is to flip the pan.
Okay. Thank you.
No problem, sir. KingHome has also case coil. So from 2 ton to 5 ton as well. Case coil, the thing is, it's really cool is you will have some service valve on those case coil, also with the air handler, but you will find service valve at the outdoor unit, but also at the indoor unit. So that we will talk about it later on, but this is a good thing to know on those type of coil. So 4 different kind of case coil can be matched with the outdoor unit. So again, you will have your dimension right here. So for a 2 ton and a 3 ton case coil, it will be 17 by 21. And for a 4 ton and a 5 ton unit, it will be 24 by 21. So you will have to match your ductwork to be compatible with those width and depth. But if it can fit directly on the furnace, well, that's a good thing. But make sure you have a proper ventilation that's going through that case coil. So this is like if you fit the case coil here, the 2 ton with a 3 ton unit, because we're going to see it later on, but we have only 2 different kind of outdoor unit. One that can be selected as a 2 ton or a 3 ton, and the other one as a 4 ton or a 5 ton unit. But if we talking about just a 2 ton installation, you can have a proper different CFM that is the minimum recommended through that type of case coil. So 800 CFM for a 2 ton. You cannot do less than 1,000 for a 3 ton, 1,200 for a 4 ton, and 1,500 for a 5 ton unit. So what's inside of that kind of case coil? So again, it will be 2 different pans, so you can flip the case coil. So it can be vertical, it can be horizontal installation. And what's inside of it, you will find a TXV. so a thermal expansion valve. So this valve here will be managed from the pressure of the refrigerant and the temperature of the suction line, but it will not be an electronic, it will be a thermal expansion valve. You will find also in the inlet and the outlet of this valve, you will find some strainer. So make sure when you will do your brazing to flow the proper amount of nitrogen through it to avoid to have oxidation into your line, because if you get some oxidation, they can block those kind of strainer. So you have two different strainer into it. Also, you will have some service valves, so a 3/8 and a 3/4 for any kind of tonnage, so 2 ton to 5 ton. And yeah, so if it's installed vertically, well, your blower can be up the case coil, or it can be down. But in that case of a upflow or downflow installation, so sometimes you will need to have a transition installed to fit with the case coil, but just be aware that you need to fit the dimension of the case coil. If it's an horizontal installation, then if it's a left orientation, well, you don't have to change anything from the case coil. But if it's a right horizontal installation, you must change the drain pan. So here about the drain. So we're going to just focus here on this little vent here. This is really important. So you have a 3/4 outlet here for your drain pan. The P-trap here on the picture is clearly optional. You don't have to install the P-trap, so it can be straight like this. But the important thing is when you do a installation of a case coil here in the supply air duct, well, you will get high pressure ventilation here. So air will push air into your drain. So if it's a separate drain like this, you won't face any issue with it regarding your furnace. But sometimes when you join the drains together, well, you need to have a proper vent here to make sure you will not push high pressure ventilation back through your furnace's drain. So because that can cause you issue with the pressure switch or something else like that. So that can cause you some issue in heating with the gas furnace if you have always ventilation pushing here into the drain. So make sure you will get a vent here to reduce the pressure in the drain pipe, and then you will be good. Next thing here, when when your installation will be done, well, an important thing is to take your static pressure measurement. This is very a thing. You need to know exactly how much inch of water column you have in your ductwork when the unit is installed. So if it's an air handler, your A coil will be in the return side. If it's a case coil, well, it will be in the supply plenum. But at this point, it doesn't matter which one is the first, so the coil or the blower. You need to have a digital manometer to be able to measure what's the return air static pressure and the supply air static pressure. When you have this number, you can always refer to your furnace manual, or instead of, I put here an example of the electric heat air handler. So then you can always refer to this number right here. So this is your static pressure. So this systems can be used to a 0 static pressure from 1.0. So anything between that, you need to match the proper speed to get the right amount of CFM through the coil. So just remember that for all kind of installation, you need to have 325 CFM per ton as a minimum, and you can go higher than 400. Okay, if you go higher than 400 CFM per ton, sometimes you will keep the water into that coil here because you have too much pressure, too much air flowing through the coil. So maybe you will get some water damage inside of it. So make sure your static pressure is good regarding the chart for the CFM. This is really an important thing to do when you will do your startup. So be just aware that you will need to use a digital manometer to find out what is your static pressure in both ductwork, so in the return duct and in the supply duct. You need to have both measurements to find the right number right here. Do you have any questions on that? No? Rachel, do we have something
Nope.
on the chat right now, or
No. Nothing. Well, I guess either
We're
I
good.
guess we're good. Okay. We'll
We're
keep
good.
going.
Keep going.
See, I don't think these guys aren't shy. So Francois, they usually will ask if they do. So, but yeah, let's keep going.
Yeah, okay, no problem.
Yeah, dude, great job. Thanks.
We're gonna move forward with the outdoor installation. So as I said earlier, we have two types of outdoor unit. So it's called a 3-ton and a 5-ton, but it can be managed, like it can be, it's configurable as a 2-ton or a 4-ton unit. Either way, each piping size will be 3/8 and 3/4 for any kind of installation. The maximum pipe length, it will be 98 feet. And the biggest drop you can avoid between the indoor and the outdoor unit is 49 feet. So again, when you will install this big guy outside, make sure you will not affect any way the neighbor. So just make sure you have a good site for the installation. Be sure you have a good ventilation also. So all around the unit to make sure you will not recycle the air of the unit. The air inlet and outlet should be far away from obstruction, so not too much closest to the wall. We're going to see that in a couple of slides. Make sure you select a dry space, so a dry place, so to not have too much water falling or ice on the unit. So typical thing you need to watch before you will do your installation, also regarding for the safety. So around this unit, the thing is you need to just know what dimension you need to, what is the clearance requirement you need to make around this type of unit. So if you're looking here as the little b right here, so behind the unit, you can be as close as 4 inches from the wall, okay? The little a right here for installation and servicing, well, 12 inches is the minimum required. Little c right here on the left side of the unit, well, you can be as small as 4 inches right here. And on the top panel right here, little heat, we're gonna ask you to have enough space, like 40 inches, because if you have to do some servicing, you will have to remove this top cover to get access to some parts into that unit. So just be aware that you will need to remove this top panel if you need to do some servicing on this unit. Little D in front of the unit, well, you will have some hair passing through that coil, and the outdoor fan motor will push it. So a minimum of 40 inches in front of the unit is required, just to be sure that you will not recycle the air of the unit. If you do multiple installation, well, clearance requirement will still the same. So just keep a minimum of 16 inches between those units, just to make sure you can access it, like really to get an easy access to the panel. If it's a row installation, well, in that way, all the unit must be back to back like this. So you need a minimum of 8 inches. And if units are facing away like this, you need to have enough space. So maybe 160 inches difference between those two units. So this is really important to not blow the hair of one unit into the condenser of the other one unit. So this is an important thing here if you do some row installation. If it's an installation above another one, well, the thing is, you will have to manage the defrost here. So you will have some water falling from the unit from the top. So make sure you have enough space to manage that condensed water and not build a block of ice on the unit below. Again, make sure the system is higher than the average snowfall in your region. Here in Quebec, everything is higher than 20 inches. So make sure the snow will not block the condenser in any way. So you need to provide a rack high enough to manage the defrost, the water coming from the units, and also the snow level. We're gonna see how these units work. So for this kind of unit, you will have your compressor right here. So the compressor will take your low pressure gas and it will compress it to a high pressure, high temperature refrigerant. So directly from the discharge line right here, we're gonna pass here in the reversing valve. In that scenario, we are in cooling mode, just to be aware of it. So the reversing valve here manages the flow of the refrigerant if we are in cooling mode or in heating mode. So now we are in cooling mode, so the reversing valve is not energized. Okay, 0 volt here on the reversing valve. So it's gonna flow through the reversing valve and going to the outdoor unit, so your condenser. And then at the outlet of the condenser, you will hit the first electronic expansion valve. So this valve here will manage the refrigerant just to make sure your 100% liquid refrigerant after your condenser. So after that valve, you will be 100% liquid. We're still in the outdoor unit, but he's gonna fill up a gas liquid separator. So you will have one cylinder right here, the pipe going down here in that cylinder, and then on the other side, you will pump only the liquid. So you still 100% liquid refrigerant in that cylinder. It's going to flow from across a one-way valve. So this is a check valve right here. So we will not use the electronic expansion valve number 2. We're going to see it in heating mode, what this guy will do. But for now, we're going to hit that check valve. So the refrigerant will take the easiest way to flow through it. So we will take that check valve, and then we will go at this point at the indoor unit. So either if it's a air handler or only a case coil, any type of case coil, well, you will hit your metering device here in cooling mode. So it will be your TXV. So at this point, after that TXV, you will be low pressure, low temperature refrigerant. So you're still in liquid. In the evaporator, you will absorb the heat, and then you will get some vapor, low pressure vapor refrigerant right here. So after that, it will going back to the outdoor unit, flowing into that reversing valve, and then go back into the accumulator. So you will hit here another cylinder that prevent this accumulator will just protect the compressor to not pump liquid, because the compressor can only pump vapor. So this pipe here going down here, you can have some liquid refrigerant into it, but this one just stop at the top of the accumulator. So you will just take the vapor refrigerant and then compress it, and you will cycle it again. If we are going in heating mode, then the small differences between those two is when you will start the cycle with the discharge high temperature, high pressure refrigerant, then your reversing valve is activated. Because it's activate, a small the valve here will change the refrigerant flow. So you will take your high pressure and push it into your indoor unit directly. Then the air will cool down the high temperature here. You will have a kind of flashing refrigerant, so high pressure liquid, high pressure vapor. You will hit the bypass here in the TXV, and then going back to the outdoor unit, you will hit the electronic expansion valve number 2. So because in cooling mode, this one was a check valve, it will be blocked. So the refrigerant cannot flow into that direction. You will need to pass into that EEV. This one here will just manage the system to make sure you have 100% liquid. So the liquid line is 100%. So you will fill up this gas liquid separator again, take 100% liquid from this separator, and then going to your EEV number 1, this one now will act like it will be your metering device. So on the other half of this valve here, you will have low pressure, low temperature, and then you can go to the outdoor coil to absorb heat from the outside temperature, and then going back to the compressor. The thing is, they had also an electromagnetic valve right here. This valve here is connected to the gas and liquid separator, but only from the top. So if we look here on this diagram, you will have high temperature refrigerant, liquid in the base, and you will have some vapor on the top here. So when the temperature is very low outside, very cold weather temperature, well, this valve here can be active for like 1 second, 2 seconds. You will hear the clicking noise of it. Just the compressor here will just take some high temperature vapor and it will be introduced into the compressor. So you will see a compressor with 3 lines into it. So it's called a vapor injection directly in the base of the compressor. And this technology here will produce some heat in the base of the compressor. So the compressor can easily compress the refrigerant. So even if it's really, really cold outside, you will have a good pressure in your system to make sure you have enough heat in the indoor unit. So you can see here on this picture that you will find your discharge line from the top of the compressor. You will find your suction line here passing through this accumulator right here. And this is a twin rotary compressor. So you have 2 plates here. And then your low pressure refrigerant will flow into that direction. And when it's provided, when it's very cold outside, well, your electromagnetic valve can open and inject some high temperature vapor into it. So that will help the compressor to make its job properly, even if the pressure is going very low pressure on the suction line. The mid-jet port right here will inject some heat and bring the compressor to a good compression cycle. So this is why we can use this system till minus 30 Celsius outside. Question about that? No, it's good. We're gonna move forward with just the some parts you will find into it. So every unit has a baseband heater. So this baseband heater is a 160 watts. It will be active from the electronic board at +1 degree Celsius and below that. And it will be disabled when you hit that +3 degrees Celsius. You can also find some pressure switch. So you will have a high pressure and a low pressure switch. In the case that those guys open, you will have error code related to it. But just be aware that the low pressure switch will open if it's less than 7 psi into the unit, and it will close automatically over 22. The high pressure switch will be open if you are higher than 667 psi, and it will be closed automatically when the pressure go down to 551. Also, in those systems, you will have those kind of EEV. So we saw on the diagram, you have EEV1 and EEV2. And also in the indoor unit, you will have your TXV. So you will have 2 electronic expansion valve and 1 thermostatic expansion valve. these kind of valve here working, you have a magnet into it, and you have this electronic magnet over it. So the head over the body right here. This kind of valve will rotate, and you have a small needle inside of it. So the needle can go up and let the refrigerant cycle into it, and then it can be pushing down and reduce the pressure flowing across that valve. So just be aware that when you see those kind of bubble on the piping, those are strainer. So if you have some impurity in the system, if something's blocking where the refrigerant is not going through the valve correctly, sometimes it's maybe the strainer. So just to make a small review here on that diagram, just to make sure you understand it correctly, the first expansion valve here will provide subcooling in cooling mode. So just make sure you are 100% liquid refrigerant after that valve. But in heating mode, when the flow is reversed, it will act like your metering device. The second one here is bypassed when you are in cooling mode, and it will perform like your it will just make sure you are 100% liquid from the other side when it's in heating mode. So it will provide you subcooling in the heating mode, and then your thermostatic expansion valve is your metering device in cooling. On this, so we saw here the low pressure switch, the high pressure switch, and you have also a parts called the pressure transducer. So the pressure transducer here is located on the suction line. So it will read the pressure in cooling mode, and it will be your discharge line in heating mode. And we will use this device to calculate the coil demand. So if the pressure is very high or very low, well, the systems in the algorithm will manage, that will drive the compressor RPM. So in other words, the compressor is inverter, it can change its capacity. Well, the pressure transducer here will be part of it to manage the RPM of the compressor. Any question? Nothing on the chat?
Nothing in the chat, Francois.
Good so far.
Crickets.
Yeah, crickets.
Love the
Okay.
explanation of the injection from the electromagnetic side of it. It's awesome.
It's EE.
Yeah, good job, Fred.
Yeah, that's great.
Thank you.
Good stuff. Good stuff.
So you already know how to do the piping stuff, but we're gonna review it again. Just make sure. Well, I've said it already, but from the outdoor unit to the indoor unit, you can go further than 98 feet. And if it's, for example, installed on the roof, so the difference between those two units, so the outdoor and the indoor unit, cannot be more than 49 feet. Also, make sure when you will do your piping to have clean pipes. Like, it's very important to do not have impurity into your refrigerant line. So make sure you pay really good attention to if you do a pre-install piping set, make sure you will flow some nitrogen into it, pinch it, braze it, make sure you keep pressure into it. So just to make sure you keep the impurity away to get inside the piping. So this is really important here. When you will do your brazing, you need to apply nitrogen till you are brazing the spot, because the effect of it will create some scale, some oxide, and the oxide, you can see it from outdoor the piping, but it will be create also inside of it. So make sure you flow like around 5 psi of nitrogen during all the time you keep brazing your piping. So this is you need to flow the nitrogen always when brazing the piping. This is really, really, really important. Now, any kind of units have strainer. Already talked about it. So you will have strainer, you will have EEV. Those EEV, you have like a small needle hole into it that will manage the refrigerant flow. So if a scale from brazing just detach and flow it with the refrigerant, so that can block any kind of valve that can block the strainer, all the things. This is a picture of just what it's looked like. Well, when you don't flow the nitrogen, you will create oxide, some scale inside of it. So you can see outside of the pipe what it's looked like. Everyone saw that. But it's doing the same inside of the pipe. When you flow nitrogen, you will see from the outside of the pipe the same kind of, you will see your flux and all your welding on it, but inside of it, it will be clean. So it will be very, very clean, no oxidation at all, and then you will protect the systems like this. The refrigerant will act as a kind of solvent, so it will dissolve and powder the oxide. So you will not see some big chunk of scale into the system. That will create like just a small powder, some residue. So that kind of residue can, not from the start, maybe, because the strainer will keep this, will hold that kind of powder, but if it's hit the EEV, well, then it will be really hard to service the unit, and then that will cause you big trouble. Unit came with some kind of already flare connection, okay, from the outdoor unit and the indoor unit. So you can use those connection here. It's already flare. You can just connect directly on the service valve right here, and then you will have to do a brazing connection right here. So again, flow your nitrogen. It's really important to make a good connection right here. So from the outdoor unit, if it's a 2-ton unit, well, the connection is inside the unit. So you need to remove the panel to make a good bend of your piping right here. So this is why the connection is already twist a little bit. That will help to make your bend and move the piping out from the corner panel. But again, make sure you make a good connection here. Use your torque wrench also. This is really important. So make sure you make a good flare connection. To make it, you can apply some compressor oil or vacuum oil around this outdoor section here of the flare, just to make sure you remove the friction. So you don't, when you will use your torque wrench and another Westcott or another spanner to hold the second part here of the piping, well, you don't want to make it twist on the flare. You need to make it smooth connection, like it will be very compressed, very hard. So if you apply a little bit of oil into it, just on the piping directly, that will help to reduce that friction. Also, when you do your piping, just make sure the piping is not really tight attached on the houses or on the wall or anything, because this kind of unit, you will use it in cooling mode and in heating mode, so you can have a lot of movement from the piping just by because when the copper will catch some heat, it will expand a little bit and it will contract a little bit when it's colder. So make sure you have enough flexibility into your piping set, just to make sure you remove the pressure here from your flare connection. Because if sometimes installation's looking very great, everything is in line, everything is tight, you have a lot of attached on the wall and nothing's moving, but then when the piping tries to naturally move because of the expansion and contraction of the copper, well, the weak point is your flare connection. So it can cause a leak in a year, 2 year, 3 year. Even your flare is perfect. It's natural, like the copper will move. So make sure you can you had enough flexibility into your piping line to avoid those kind of problem. So to avoid that kind of leak in a couple of years. So using your torque wrench, be sure you apply the right torque on it, because it's a 3/4 flare connection. It's hard to know exactly only by hand how many pressure you applied on that connection. So using a torque wrench is a must. It's really important to know exactly how much pressure you push on this little nut right here. The refrigerant line passing through a hole in the corner panel. So just make sure the hole is blocked. The knockoff hole will be blocked after you have done all your stuff, even from your low voltage wire, high voltage wire, and then from your 3/8 pipe and 3/4 pipe. So, you know, unit is installed outside, so maybe some small animal can just enter because it's warm inside of that cabinet. So if you don't want to have a small mouse is eating all the electronic stuff inside of the unit, so make sure the hole is sealed properly. So this is an important thing to know too. So leak test. As I said, you will find some service valve at the outdoor unit, and you will find service valve at the indoor unit, even if it's a case coil from KingHome or a air handler. So the thing is, inside the case coil or the air handler, there's already a small amount of refrigerant, like an half ounce, like 9 ounces, something like that. So an half pound of refrigerant is already into that indoor coil. So you will have, just to make a good leak test and a good vacuum, into your lines only. So one for the liquid line and one for the gas line, okay? The vapor line. So you need to provide your leak test like around 500 psi of dry nitrogen, and your pressure must be held for like an hour, just to make sure you don't have leak into it. You can also use your soap just to make sure you won't see bubbles, you won't see anything from your flare connection. So make sure when you apply the soap, let it there for 15 minutes minimum, because soap needs to have some, like a small amount of time to make a good contact around the pipe. So 15 minutes, you need to lay down your soap on the flare connection. And when it's done, you can remove your nitrogen from the system. So make sure you don't have any leaks, and then you can perform the evacuation, the vacuum. So you will attach your vacuum pump, and then you will need to make two different vacuum, one for the liquid line and the other one for the vapor line, because the coil is already holding some refrigerant into it, so it's not communicating from one line to the other. So you make sure you will do two different vacuum for each line, because you do vacuum only in your line, so it won't take you a long time to make it a good vacuum. So make sure you attach your micron gauge. You will reach your 500 microns. Hold it for 15 minutes. When it's under 1,000 and stable, then your system is dry and there's no leak. So you can go and open your refrigerant line. So you will have to open 4 service valves to make it work properly. 2 from the outdoor unit and 2 from the indoor unit.
Hey, Francois,
Yeah.
do you recommend maybe cracking the indoor service valves first? Is there a particular like, which one do you prefer? Like, should we open, like, when we're ready to release the refrigerant? Would you prefer, release just opening up the indoor, then running out doing the outside, or the outside first, then the indoor? Doesn't matter.
It doesn't matter. The thing is, well, what it's matter is you need to open the liquid line first, okay? Just make sure you will push enough liquid into the system in the first part, just to not, because if you open the vapor line first, sometimes, not every time, but you have a risk of just, because of the pressure drop, you can suck some oil from the compressor. So always open your liquid line first. And what can be done, you can just make it a cycle, like your liquid line from the outdoor, and then you can open the indoor valve and finish with the suction valve at the outdoor again. So make it just a full circle right here. And also, another tips and trick you can do is you can just crack the valve a little bit and close it already. Just make sure you apply some pressure into your pipe, and then you remove your gauges at this time. If you don't want to take the if you don't want to lose too much refrigerant, so you can remove your gauges already at this point if you have done with it, or if you want to make your test and everything, you can let it there. But the thing is, you can open the liquid line from the outdoor unit first and then make it cycle. Just be sure you open all the 4 valves at the end.
Thank you.
The system is pre-charged for 31 feet, so total. Standard line pipe length is about 25. The minimum is 10 feet, okay? You will not have to remove refrigerant from it because the system's already using that liquid cylinder that will hold the charge right here, and you have your accumulator that will protect the compressor, so you don't have to remove any charge of refrigerant. But the system is already good for 31 feet. If you have more than that, you will need to add refrigerant. So 0.36 ounces per feet over 31. The insulation, well, only the suction valve, the suction pipe, sorry, needs to be insulated. The 3/8, it's a real liquid line, so it doesn't have to be insulated. If it is, it's okay. But if you do a retrofit and the liquid line is not insulated, so that's perfect, that's good. We don't need to insulate it, the liquid line. Make sure when you do your, you will add your Armaflex into the pipe, like to make it a good contact, not let it, the air or the water can condense on the suction line. So make sure your Armaflex is, you have enough of it and it's tight, so it won't produce any condensate water on the piping. So on the outdoor of the valve here, so on this picture, this is an example of a 5-ton unit, so a 4 5-ton unit. So for this kind of unit, the valve is outside, but well, the 3/8 is not insulated, and you will push your Armaflex as far as you can go on the valve here. So in a certain point, yes, this valve may condensate, but it's a normal thing when you are in cooling, and this valve is outdoor. But just remember, you will hit the same kind of valve on the indoor unit. So just make sure if you have like 3-4 drops of water below the valve here, it's normal. You can add more kind of Armaflex, or you can isolate it as well. But just be aware that this is normal for the system to condensate on the suction line here at this point. Any question about the piping and all the stuff we've seen so far?
The chat is clear, Francois, so nothing in the chat, so.
Okay, that's great.
Yeah.
Actually, Tommy,
Yep, sorry.
I did have something in the chat. It's just not sending for some reason.
Oh.
So back a few slides ago, it says digital gauges. Is that mandatory?
It's better.
I
Well,
wouldn't say mandatory, yeah.
yeah. So we are in 2024 now. Digital gauges are awesome. You can also now have your temperature probe on it. Well, it's a thing. It's a thing. Like, the industry is moving forward. Now they are good. I used mine back in the days, like in very cold weather outside, and always worked perfectly. I have more reliability onto my digital gauges than my the one with the needle. So yeah, I hope everyone will moving forward and use digital manometer. Okay, so now we're going to talk about electric connection. Are you guys going to install some of those air handler in your region? Do you install like electric air handler or not at all?
Very little, like maybe like 5%. Like mostly it's, I'd say 95% gas and then maybe 5% air handler. So not too much. But we can touch on it if you want to go over it a little bit. Yeah.
Yeah, I will just not
Yeah.
take a deep dive into it, like
Okay.
the heater and all stuff. Even you have some questions. I have all the slides on it, but yeah. So here for the electric air handler, if you don't had any kind of duct heater into it, you just using as a case coil, for example, you will need to power it like 240 volt, one phases, and just a 15 amp breaker. Okay, so you have the electrical box into it right here, and you will find your L1, L2 connection right here. The thing is, you will have some knockouts connection on the right side and on the top panel right here. I highly suggest you to use the one from the side, just to make sure you can remove this top panel if you need it. So in a case that maybe in a year or two you will have you will change your power supply line and you will have a 5 kilowatt duct heater, then you will have to remove this top panel here to make a good installation. So just make sure to use the side knockout here of the air handler when you will install it. This is just a tips that I give it to you. Already said it, so make sure if you install an electric heater to make a good check here with the chart to which one you can use and which one you can't use with this kind of to matching your air handler with your duct heater. Inside of the cabinet, it's looked like this a little bit. So now for the picture, the top panel is removed. Okay, so you see you have the back plate here for the duct heater. You have a breaker holder into it, and you have this electrical box. So if you need to install a duct heater, you will need to remove this box temporary. So you have two screws holding it. So you can remove this this box here temporary. That will make you enough space to have access to the back plate. You can install your duct heater, and behind the cabinet here, you have two little holes that just to push the bracket into it. Make sure the duct heater is not swinging in the supply duct. So make sure you push the bracket into that hole here just to make it stiff and make it hold it correctly. Then you will have to replace your screw into it. Then you will install the breaker. The breaker comes with the duct heater. If it's a 5 or 10 kilowatt, you will have only one breaker. If it's a 15 or a 20 kilowatt, you will have two breakers side by side. And to make that connection, you will use a single point connection. So before that, if you are using only one breaker, for example, you will have to connect this white Molex connector. So in a case that you don't use the heater, well, you will not plug anything on this one. But in a case you use one, well, you will have to connect this plug together to make it work correctly. When you attach a single point connection, you will have to remove this small piece of metal here in the on the plate right here. You need to make sure your breaker is side by side and touching together to make a good connection with the single point here. So now, in a case that it's a, for example, a 20 kilowatt, like most of the Quebec installation here. So you need to provide a big wiring on those screw here to make sure you power the unit correctly. So by the white Molex right here, the 240 volt, it's already powered passing through the breaker here. So you don't use anymore the L1, L2 connection right here. So you don't have to. There's already a wire going from the breaker to power up the board and all the stuff for the unit. So when you're using a duct heater, you don't have to use the L1, L2 connection here. And again, you will have some space behind the panel, the box right here. So I hardly suggest to use the knockoff hole from the side of the unit and not the one from the top, because maybe at some point you will need to access the top panel here. So for the outdoor unit, the power will be, again, L1 and L2. Maximum fuse for a 2 and 3 ton system, it will be 35 amps. So a 30 amp breaker with a 10 gauge wire is good enough to make your installation. And for a 4-5 ton unit, the maximum is 45. So you will use here a 40 amp breaker with the number 8 wire gauge that's high, that's big enough to make your connection here. So when you will do your connection, it's good to have a good and solid connection on your L1, L2. If you use some spade connection, that's better. If you just lay your solid wire like this, make sure you have long enough of that copper wire here to make a good connection for your L1, L2, and your ground as well. For the low voltage connection, well, it's highly recommended to use stranded wire. But if you have some solid wire, because it's only a 24 volt connection, well, again, make sure you make a good contact here with the copper to avoid any electrical problem with the system. So this is what's looked like the terminal strip. So for the power, your L1 and L2, you will use your disconnect as well. You can use your surge protector on your disconnect or directly on the power line somewhere else. And then the terminal block for the low voltage looks like this. So you have your Y terminal. This one will control the compressor signal. You have a B terminal right here. This activates your four-way valve in the heating mode. So you need to configure your thermostat to be active in heating mode while talking about the four-way valve. The D connection right here, it's a output signal for the defrost. So in a case that you will need to enable the furnace or your duct heater during the defrost of the outdoor unit, well, you will need this D connection. In other case, well, if you don't want to provide heat during the defrost, because the defrost cycles, it's very short, and you don't have to apply any heat during this time, well, the D connection is optional. R and C is your power for the 24-volt connection. So R, it's always your power. C, it's the common. And the G terminal right here, it's not in use. So there's no connection into it. It's just like laid there. There's nothing to do with the G connection. Make sure when you will get the wire across the corner panel to use proper hole into it. So one hole for your high voltage line and another hole for your low voltage line. Make sure you're not passing from the same hole. You have access from the side, you have access in the front, and you can have access from the back too. So multiple way to install your wire to make sure you have a proper connection from your L1, L2 right here, and your low voltage connection just beside of it. On a 4-5 ton unit, the unit is taller because we use 2 condenser fan, but the hole can be found here somewhere in the middle of the height of the unit. So one hole for your high power and another for your low voltage connection. So we saw here the connection for the outdoor unit. You have your thermostat into it, and then this is an example of your indoor unit if you have a electric air handler. So again, you can find you have a D terminal right here. So if you need to use it, you will connect the D to the D. You have a B terminal for your reversing valve, W1, RC, and now the G terminal is for the call for the blower. So in that case, the G terminal is in use when you have a electric air handler. I build up this kind of diagram to use it as a reference. So in that case, we use an Ecobee thermostat. Sorry, an Ecobee thermostat. So from the thermostat, you will use RC when talking about Ecobee. You won't use RH. I know new kind of thermostat from Ecobee only using the R. There's no more RC, RH. You just have a one R. But in the case that you have both, well, you need to use the RC. So from your thermostat, the minimum wire you need is a 6 wire coming from the thermostat. And all those wire will be connected to the furnace board. So in that example, this is a Lennox 2-stage furnace. So you will have your Y1, Y2, C, R, G, Y, and a O terminal right here. O and B terminal are both for the reversing valve, but in that case, you need to cut the wire jumper just below that O terminal when it's a Lennox 2-stage furnaces. Well, and in the Ecobee thermostat, you need to configure the reversing valve engage in heating mode. So this is why it's called on B when it's engaged in heating mode. But sometimes you can see a label O. So O and B, it's the same label for the reversing valve. from the outdoor unit, if you don't need the D terminal strip, so only 4 wires are required to have a full configuration for this kind of unit. If you will use the D terminal, I can suggest what I did in the past when working with the gas furnace. The D terminal here can be plugged with a limit switch. So what we've done is this kind of limit switch can be installed between the case coil and the furnace. So somewhere under the A coil, but after the furnace. So you need a perfect spot in the supply duct. And then what it can do, this limit switch is like directly, it's normally closed limit switch, and it can open at 100-degree Fahrenheit, for example. So what you can do with the system is when you will have a call for defrost, you will push 24 volt from the limit switch. Limit switch is closed. So you will have this connection going to your W1. So the furnace will start, okay? During the defrost cycle, the furnace can start, and then when you will hit 100-degree Fahrenheit, well, the limit switch here will open. So that will cut off the W1 call, so the furnace will stop. That will provide heat in the plenum enough to not feel that cold draft air, but you will not heat the refrigerant enough to make it boil. So just during the defrost cycle, when it's done, well, the unit will go back into heating mode, and then you will heat the house with the heat pump again. So the D terminal here just connect to W1 to prevent from the cold draft into the house, and that's it. So if in your region you don't use the heat pump at very low temperature, well, the defrost will not take too much time, so you don't, maybe you don't have to connect it already, but from a Quebec perspective, or when you're using an electric air handler, well, now maybe at some point it's good to have this W1 connected with the defrost. The thing is, when you do the configuration here, because the supply, the coil is in the supply duct, you cannot use the furnace and the heat pump at the same time because of exactly what I'm explaining. You will push some hot air into the coil, you will make the refrigerant boil, and then that will give you a high pressure issue. But in the case that you have an electric air handler, well, the coil is in the return side of it. So you can use the duct heater and the heat pump at the same time. So this is why in that case, we can connect the D to W1 to engage the duct heater while the system is in the defrost, because you will not make high pressure because the heater is in the upper flow of the system. So just a little bit of security things here. Make sure everything is connected properly. So your high and low voltage wires should be led through different rubber rings. So make sure you don't bundle the thermostat wire. to not create some kind of error and stuff like that. So high and low voltage must be separate, and make sure the wire is held properly. So sometimes you can add some clips or stuff to just hold the wire correctly. Make sure you have a proper ground too, also from the your furnace, from the outdoor unit. The ground is really important. We have a lot of like communication inside of the unit. You don't send communication to the outdoor unit, but inside of it, there's a lot of communication because the compressor is inverter. It will be driven from a kind of back and forth communication. So you need a proper ground to make it work correctly. And so always use your local and national rule about the power and the connection and all the stuff. We're going to move forward with the test and run, the start-up operation. Any question about the wiring?
Actually, I got one question.
Okay.
When we're running it, you said just run a 15 amp to power the indoor unit.
Yep.
Should we be just running like 10 to, like, how much increase is it if you add those heaters? Like, do you have to run a new wire, or will it still operate on the 15 amp?
No, 15 amp is only when you don't have duct heater.
Okay. Do you have the, like, if you were to add the biggest one, I think you said was 20?
Yeah.
20 watts. So what would that in amps be? Like, what should we be running?
100.
That's
So-
100 amps?
Yes. For 20 kilowatts, you need 100 amps breaker.
Okay. So yeah, then we're not running that. Yeah. Okay. So we're just gonna do the 15 and we're done.
Yeah, if you don't use any kind of duct heater, you can use only a 14 gauge 50 amp breaker, because the only thing you powered here is the fan and the electronic board.
Okay.
So it will like consume like maybe 3 amp on it. Like it's very low. But when you install, for example, it's by for a 5 kilowatt, for example, the 5 kilowatt will take you like 20 amp to run it, plus the blower, the board, and all the stuff. So you need a 30 amp breaker just to run a 5 kilowatt duct heater.
Okay.
Okay. If you go to a 10, you need to add 20 more amps. So it's a 50, but you can do 50. Really, it's a little bit too close. So you will go to a 60 amp breaker for a 10 kilowatt.
Okay.
And you add it on and on and on like this.
Okay.
So it's not really 20. It's a little bit less than that. So this is why for 15 kilowatt you can go for 80 breaker amp. But for 20 kilowatts, well, yeah, you need a 100 breaker amp.
Okay. Yeah, I just wanted to know if it's something that we, if it's wasn't that much more, we just run the wire and then it's ready. But no, this is going to be something that they're going to pay for later.
Yeah. Yeah.
Okay.
But in the case that maybe you need to add like 5 kilowatt, if you passing already a 10 a number 10, so for a 30 amp breaker, well, you're good. But the case is just to make it good in for electrical law, if you passing like a bigger wire gauge, you need to install the proper breaker to it.
Okay.
Okay.
Thank you.
No problem. So when you have done all your installation, so wiring is good, piping is good, the clearance is good, everything is awesome. So just make a quick check over what the unit is, if it's properly installed and all the stuff is good. So confirm your voltage. Make sure you have good voltage from the panel before turning on the unit to not damage any in any way the board. Make sure you don't have water or something around the unit. Make sure everything is good and clean, and the clearance are respect, and you have your proper ground, all the stuff like that. This is really important. In this unit, the outdoor unit, you will have some dip switches to configure regarding what kind of installation you did. So for example, we called the unit like a 3-ton or 5-ton, but it can be configured like a 2 or a 4, depending on which cabinet you're using. So for example, we're talking about a 3-ton unit. By default, it's configured as a 3-ton unit. If you have installed a 2-ton case coil and you want to run the outdoor unit as a 2-ton, will act as a 2-ton, you will need to move the dip switch number 1 to off position. So now the dip switch number 1 will act like your capacity dip switch. So by default, it's set on for this kind of cabinet right here. By default, it's on. If you need to get like a lower capacity, you will need to put it off. For the other cabinet, like the 4 and 5-ton, well, by default, it's on to act like a 5-ton. If you need to make it 4, well, you just push it off to make it 4. So dip switch number 1. Dip switch number 2. So this is the same block here, but we are just moving to dip switch number 2. It's your defrost mode switch. So if we go back here, you can see your dip switch number 2, even if the by default it's on. So for a 3-ton or 5-ton, by default it's on. So on means standard defrost. So the algorithm of the unit will use standard defrost. So depending on time, temperature, all the stuff to make the defrost happen. So it will be by default. So you let it on. If in a certain case you have some ice built back in the unit, you have some difficulty to remove the ice, the snow of it, you can make it a strong defrost. So just put the power off, wait 15 minutes, then move the selection here of your dip switch, put it off. That will make the systems go into a strong defrost. So it will act the defrost more rapidly, and so you have more chance to remove that ice and snow stuck into the condenser coil. The 2 last ones, so the 3 and the 4, are for operating mode. So by default, they are off, meaning it's standard mode. So standard mode, the system will act as it's supposed to be, and no question asked. In a certain way, if you need more power from the unit, like more quicker, you can set it as a strong mode. So by flipping the dip switch number 3 on and number 4 will stay off, that will gives you a strong mode. So the compressor will ramp up more rapidly to reach the maximum BTU and gives you more power, more heat into the house, for example. Or you can do on the other way, you can select energy saving mode. So by flipping the dip switch number 4 to on, well, you will get energy saving mode. So the compressor will stay at a low capacity for a longer time. So, for example, you set up like a 3-ton unit and the ductwork is designed as a 3-ton unit. You adjust the CFM, you adjust the airflow, you adjust everything, but still you don't remove enough humidity in the air because it's too fast. You're in cooling mode and the units operate only for 15 minutes and it's done. It's cold, but it's still humid in the house. So at a certain point, you can use that energy saving mode to reduce the capacity just a little bit of the compressor. That will make the systems run a little bit longer. Maybe you will hit 20, 25, 30 minutes of running time, and then you will start to remove more moisture and more humidity, more moisture in the air. So then the homeowner will be more comfortable into his house. So this is some kind of tips that you can use like only by flipping some dip switches on the board. So this is really awesome from this unit. You can really act or like configure the system as you want it to be.
We're going to say yes.
So a question for you, Francois. It's
Yeah.
John. Do those modes also represent the operating modes for in the heating mode as well, or is it
Yes.
just in the cooling mode?
No, it's for heating mode as well because it will manage the compressor frequency.
Okay, so it's so I do have one installed at my house, and I was just understanding that yes, it was meant for the heating mode. It just didn't represent that in the literature that it says it talks about the air conditioning mode.
Yeah, but it will be acting directly with the frequency of the compressor. So yes, maybe you will just smooth if it's on energy saving. That will lower the capacity of the compressor for a small amount of time. So it will be able to reach 100% of its capacity, but it will just take a longer time to make it.
Okay, that was my second question. Will it make it to 100% capacity? And you just answered my question. Thank you.
Yes, it will. And if it's in the reverse time, well, if you put it on strong mode, when it will ramp up very rapidly to 100%.
Yes, I've tried that one. It does.
Okay.
It ramps up very rapidly within 10, not even 10 minutes. It's at high speed and creating a lot of heat. Awesome. Thank you.
So okay, thank you. The thing is, what it's look like on the board, I know it's a little bit hot, but the dip switches are upside down. Okay. So meaning that when you will look your 1, 2, 3, and 4, the off position is on top and the on position is on the bottom. So you can refer to the same kind of what you're looking here. Two different ways to make it. You can take you can print it and just flip it on the other side just to make sure you have a good vision of it. Or just imagine that this one is, you need to flip it upside down. So it will be correct for the next generation of it. But for now, I know it's tough sometimes to manage how the dip switch are selected, but when you know it, you're good. So for example, this block here, if we looked at it, so we know by default the number 1 and 2 are supposed to be on. So this board here is a 3-ton unit. So it's a 2 or a 3-ton unit. So by default, number 1 and number 2 are on. So I know just by seeing this that my capacity here is select as a 3-ton unit. The dip switch number 2 is set for my defrost. So I know because it's on, it's a standard defrost. So if I flip it off right here, I will get a strong defrost. But for now, my configuration is standard defrost. If I look here, my dip switch number 3 and 4, if I refer to my slide before that, so they are supposed to be off to get standard mode operation. But because I'm on and off, if I refer to this one here, number 3 is on and number 4 is off. So my system is now in strong mode. So you can see here, I have a 3-ton unit, standard defrost, strong mode is activated by the 3 and the 4. And that's it. This is all you need to know about the dip switches when you will do your startup. So make sure when you are in cold weather, okay, so when it's really cold outside and you've done your outdoor installation, don't be afraid just to apply power on your L1, L2 on the outdoor unit before even you finished your piping, just to make sure that the compressor will be warm enough to make a proper startup at the end of the day. So this is really important. You need to activate that heating shell of the compressor during the day when you're installing the system, when it's cold temperature outside, just to make sure you will not slug the compressor at the startup, because liquid refrigerant will stack into the base of the compressor, and if it's cold, you can damage the compressor directly from day one. So you need to warm up the system a little bit. So if you touch it with your hand on the shell of the compressor and you feel it warm, you're good. So make sure to apply the power to engage that heating shell on the compressor to make sure it will be warm enough. Other thing, if the outside temperature is more than 24 degrees Celsius, then you cannot use the heat mode. Okay, so during summertime, well, heat mode will be disabled if you are over 24 degrees Celsius. Make sure everything's run normally. You will make some installs, you will hear the noise. Make sure you don't hear any knocking noise when starting the compressor or stuff like that. So for example, if it's cold and you try to start it and maybe you can hear the sound of the liquid sucking into the compressor, stop it immediately. So try to avoid to damage the compressor from day one just because you're in a hurry. Just wait it till the compressor is warm enough to run it properly. Other thing, when it's minus 15 degrees Celsius, well, the cooling mode is disabled as well. So you will not be able to use the cooling mode at minus 15 degrees. Yeah, that's it for this morning. you can have access to a startup report sheet too. It's always good to have your model, serial number, matching all your stuff.
I got a quick question.
Oh, yeah.
Before in the red, it said that you have to preheat it for 8 hours. Is there like
Yes.
in the warranty where it's going to void it if it wasn't run for 8 hours? Because it's not going to be run or heated up for 8 hours.
No, it will not, but it's highly suggest to just make it warm before you start it. So manufacturer tells 8 hours to avoid any kind of, well, if it's like minus 30 outside, maybe it will take you a couple of hours for the compressor to be warm enough for the startup. So if you can connect it already in the on the first part of your day, well, do it, because you need to feel it warm with your hand before you start it. So if it's in summertime, well, it doesn't matter. You don't have to plug it 8 hours before. But for example, if you do like a 2 days installation because you have a lot of stuff to do it and it's very cold outside, so I suggest you to start with the power for the outdoor unit. So you can just connect it and forget about it, do the rest of the work, and the second day when you go and make the startup, then you are assured you that the compressor is warm enough.
Okay.
And I'll just add to that on the warranty for the KingHome warranty with Enercare. As long as the warranty is registered, it's 10-year parts, and we don't have catches where we'll try and void warranty based on either yearly maintenance or any of that stuff. It's just a complete 10-year, and if there's a compressor failure within the 10 years, we'll just give you an entire new unit. So we want you obviously to do best practice for your installation, but we will never void your warranty over something like that. Yeah.
Okay. Thank you.
No, but we just want to avoid to have any problems at the day one.
Yes. I know.
So this
Fred
is
wants-
like
I'm
Rachel
sales,
said,
Fred wants to-
it's best practices.
Yeah.
Yeah. So and also make sure when you complete that startup report sheet, make sure to write down your static pressure as well. So it's a good thing to know when you will talk to tech support to know exactly what was your pressure, temperature, static pressure. All those kind of information help us to help you. So because if you have someone from the tech support over the phone, they're not with you on field. So if you can tell more and more information about what the your installation looks like, so that's helping us to help you. So write down maximum of information, especially from the startup, because back in the days, I remember like sometimes the startup is bad, like it's not a good installation, and it can run like this for over than a year, and then you go back as a service guy and trying to find out what's going on with the system. Is it a new problem or it's an old problem? So by having a good startup report from the beginning and make sure you have write down the right information, well, this is very helpful for your company to provide more quick services and make it like everyone happy. So that's it for this morning. So Rachel and I will stay around for a question. Don't be shy. I can go back in some slides if you need it. So still here. So thank you, guys.
I got a question.
Yeah.
For the defrost with the limit switch that you referred to, is that a kit that's going to be supplied, or is that something we're going to just have to?
You need for what ports of the defrost you're talking about?
You mentioned the high limit switch, the 100 degree high limit switch to run.
No, this is okay. So the limit switch, it's a part that you must provide. It's not something that you can buy from us, but it's just an example of how we did our installation here in Quebec back in the days. So you need to find your own limit switch. It's like easy enough to find it, but it's not something that KingHome sells, but it's just the tips and tricks to help you to manage the defrost correctly. So yeah, it's just something that you need to purchase from your hand.
I have a question.
Yeah.
Installation, when the heat pump is in heat mode, what are we setting for minimum compressor shutdown?
Oh, so I can answer that. So here in Ontario, we're basically running at maybe like on the Ecobee, you got like minus 6.7 degrees Celsius or minus 3.9 degrees Celsius. And that's not really a question of how, if the unit, I mean, these units can work up until minus 30. And like John Dirksen was saying in his house, it still puts out a ton of heat, even at minus 10, right? But you know, homeowners, you know, that's kind of up to the homeowner, and what the salesperson has communicated to them with how they want to run their heat pump. We are coming out with a 2-wire stat, which you guys are going to love. So no more running wire. It probably will be here for March. And that's going to be a smart thinking thermostat where you're not going to have to set the balance point, where it's going to take a look at the outdoor temperature, take a look at the time of use for electricity or the cost of natural gas at the time, the temperature differential it's got to overcome, and then make a smart choice on, for this particular call for heat, am I better to go aux with my furnace or am I better to go heat pump? So eventually down the road, we're going to take that away from you guys as something that you have to set. But what I found is pretty safe number is anywhere between -4 and -8 with natural gas. If it was propane, I would set my, on the Ecobee, my minimum compressor outdoor temperature, you know, -10, -15, just because cost of the propane if you're in propane. I don't know if that answers your question.
It does, yeah, just because
Okay.
when we're setting up the Ecobee,
Yeah.
so it's always going to ask you that, right?
Yeah. So that, and the setup, the setup on the Ecobee, we can run through that with you guys again as far as you know, but it's I mean, you guys are probably pretty familiar with it. But yeah, I would do about -6.7 to -4 right now. And
Yeah.
you know, that's going to change if natural gas goes up. And then once we launch the 2-wire stat, which is going to be just 2 wires up to the thermostat to power it, and then there'll be like like the old Honeywell relay panel sort of down in the basement where you're going to connect the 2 wires from the thermostat, and then you'll be able to run your 6 wires to the furnace, and then your wires to the outdoor unit. And that'll be able to be operated with Wi-Fi. But if a homeowner doesn't want Wi-Fi, it's going to be extra wires, but you can run an outdoor temperature sensor. And then that way, you'd have to actually set the balance point in that case. It wouldn't be able to be the smart thinking thermostat if it wasn't Wi-Fi, but it's going to have a lot more options.
Yeah. And Rachel,
Okay,
if I can just kind of pop in there, guys, and just to kind of clarify, Rachel, I know, you know, we had our mindset around that, you know, -6.7 or that 3 point whatever on the Ecobee. You know, in the past, we've had some issues with those types of temperatures as our threshold or our balance point. So I'm going to go out on a limb, guys, and you know, as a you know, outside of KingHome and whatnot, I'm going to go out on a limb and say, listen, let's just set these thermostats at you know, that setting of 1.7 degrees Celsius, just above freezing.
Well, what I
This
really
way, I
recommend,
I get, I get the
yeah,
the temperatures, and hey, let's let this thing run below freezing and whatnot, and let it get into defrost. And I do that in my home. Mine it's not a KingHome, it's a Carrier, but I've got mine at 6.7. It seems to work. But we've had some
yeah,
issues in the past where that where we've told our technicians or our installers to install or to set it up at minus 6.7, only to come back to adjust that because the customer's complaining, right? So
right,
to avoid that callback,
sure,
guys, installers online, let's set that threshold to 1.7 degrees for now, right? And hey, if the customer wants to set that threshold himself to a lower temperature, that's great. But to avoid any confusion, guys, let's just set it at 1.7 degrees Celsius and let the thing operate at that temperature.
And the other thing I'm gonna say, obviously when we're increasing the temperature to 1.6 or whatever,
Mhm.
and even at 6.7, whatever you set it at, disable every possible alert in the
Alerts,
Ecobee
yeah,
that you can that
yeah,
goes to the
absolutely,
homeowner, because they get the
absolutely.
aux heat running too long, then they call, they drive us nuts.
Yeah, we
So,
do have, I think John's online. I think
okay, good.
we've
Okay,
we've tackled that. I know, hopefully
okay,
the word's got out on, on the complete setup of that Ecobee. There are some other thresholds that we need to set, and that's exactly, Rachel, is one of them. So 100%.
Is there, sorry, is there management or sales or purchasing on this training?
Management as far as the field management?
Yeah. Is this all just service and installs?
It's all service and installs. We did invite some field managers, just away from, the computer right now, so I can't really see who's online.
Okay,
But, we absolutely did invite the field managers to join us this morning. We got another session tomorrow as well, so.
okay, I just wanted to know if they were gonna be putting together something like an example, that high limit switch. So that the salesmen know when they're going out and selling these, if they don't want the cool air, instead of having
Right.
a complaint, they can offer that option and have that sold and ready for us when we go out, not us trying to go and find.
Yeah, exactly. So I know Rachel and her team and Francois, I know they're meeting with our salespeople, and I'm sure that's been brought up as an option when running with fossil fuels, specifically around that Lennox product. Yeah. So Rachel, hopefully you guys are putting out that word so that as an option with that limit Francois brought up a little while back ago, as an option to for that our EMCs are aware of, right? So, and Francois, back to that limit. Is there a particular length that you're, back in Quebec where that probe, is it 5-6 inches? Is it, what size
Yeah, back in the
probe
day,
would
those
you
limit
like in the
switch
past?
was 4 to 5 inches long.
Okay, and about 100 meter on the limit, or 100 degrees on the limit. Okay.
And then,
All right.
sorry, when you're putting that in, you're just drilling a hole in the A coil, like in the case coil?
No, you're
Yes.
not drilling. No, you're not drilling anything in the case coil. So if that's going to be an option for you guys, where we're looking at putting that limit in, I would love for you guys to build a little transition between the furnace and that case coil.
Yeah, that's better.
We're not drilling anything in that case coil, but
Okay, so it's
absolutely
really
not.
important then that the salesmen know, that they tell them these options, that when it runs on defrost, that it's going to cool the house. Because if they're not going to be happy with that, we don't want to be going back and having to tear everything out just to put a transition in.
Right.
If
Now I know.
if your balance point is at 1.7, well, maybe you will not get the defrost cycle too many times.
Right.
So you don't even have to connect the D if your balance point is over 0 degrees outside.
Okay, so if we just keep it at 1.7, then we don't have to worry about it.
Yeah, exactly.
Unless they call in.
It's in the case that you go lower than that.
I would still let them know, so that it's their option. They word to decide afterwards, not us going back and eating it.
Sorry, there's a lot of background noise. I can't hear Doug.
Sorry, I was just saying, I would still let them know to tell them, because if they decide, like you said, they want to go in and set it lower and have it running on heat pump mode, or let's say gas goes up and hydro's cheaper and it's cheaper to run the hydro, that they know that this is an option that they're going to buy into or opt out, that if they decide that they want it later, we're not going back and heating it.
Yeah, but it's an option that guys, you to know it's good. It's good to know that you can do something. So if the homeowner complains about any kind of comfort in his house, and he feel the cold draft, and he wants you to make some things happen, well, I've just give you that tips that you can do something.
Yeah, no, I'm just talking to kind of everybody else like that works for Enercare, because it's usually a problem that we end up going back to and they're not told. So
No.
they were told that they're gonna have home comfort and it's making it cold. So then we go back, tear it apart again to put this in, and we eat the cost of everything. So if
Yeah.
they're told up front and they say, no, I don't want it, then we can charge them later.
Yeah.
So to give you an example, Kevin, is that the defrost cycle, when it's in strong mode, it lasts about 30 seconds and it's back into heating before you know it. And that's what I've been experiencing. So by the time you get the warm air coming back out of the registers, it's probably about a minute, maybe a minute and a half. So
Okay.
it's at a point where the homeowner, I can almost say myself, I don't even, unless I'm hearing the unit going into defrost, I never know when it has happened.
Okay.
Same
Just to
here.
give you
I
an
don't
example.
even know mine goes into defrost mode either.
Is everybody still there?
Yeah.
Oh,
Yeah.
just went quiet.
Huh.
Okay.
Okay, cool. Any more questions so far this morning?
Not for me. Thank you very much. I have to hop off. Thanks very much,
Okay,
Francois
perfect.
and Rachel and
If
all the
we-
rest that are on the line.
Thank you, guys.
If we have any,
Yeah, thank you. Thanks
Actually,
again.
a quick question. Is there a reason why on these smaller units, can we not just bring the copper into the unit and flare it instead of having to attach it and then solder it or braze it?
No, you can do
Not
the
breathing.
flare directly. If you can avoid to braze any pipe, that's better.
Okay.
do we have a KingHome contact that if we have any questions?
Yeah, I'm gonna put my contact number here. So 647-407-3402. And then it's Rachel at KingHomeCanada.com. And then we have Argon's going to be joining us tomorrow. He was not available this morning. And the reason that is that we do in-person training every Thursday morning in Vaughan at our location at Keel and 407. You're always welcome to come. We've got both the Ultranex and the Eco model, which is coming in March, hooked up there with the furnace. So it's live training. And that's every Thursday at 9 a.m. and it's 40 Great Gulf Drive, Vaughan. And yeah, so shoot me a text if you ever want to join that training. And then if you have technical questions or any of that stuff, shoot me a text. And our tech support here is 7 days a week. So if I have the tech support number, so if you need it, just send me a text and I'll send it to you. So that's a direct line to Argon, or you can also call me.
Can you just repeat
And
your
then
number
if
there?
Argon and I don't know the answer, then we're gonna call the super brain here, Francois, who knows everything, and we'll find out the answer.
We're here to
Rachel,
help.
can you just repeat your number?
Yeah, I put it in the chat, 647
Oh,
407 3402. I thought my old carrier number, like people must have been putting it up on bathroom walls because everybody had my number. So now this one's gonna have to go viral. So yeah, you can feel free to give it to whoever wants to call me. I'll talk to anybody.
thanks.
Okay.
Well, thanks, Rachel. Thanks, Francois.
Yeah.
It was really informative. So I really appreciate you guys taking the time with us this morning. And yeah, it was awesome. Good stuff.
Awesome. Thank you.
All right, everybody. Yep. All right. Enjoy.